going to have a look at how to use the GDC for the modelling task of Usain Bolt and when they'll run 100 metres in less than 9 seconds. So to start off with, you're going to go to the home page of your GDC, which you get to by clicking the On button. And then we're going to put our data in. So we need to open up the spreadsheet and you're going to put your data in, which you'll have to type in one by one, or you can copy and paste by going to the data you've got on the sheets. And then we need to put a title. The title goes in the top row where you've got the label, and there's a little picture of like a little label on there. So the first one is the years from the world record, and the second one is the actual time for the world record. Don't put anything too long in that top column, otherwise you might get errors. So if you do find you get an error message, just shorten it, and perhaps that's why. The second row, this one here, we need to keep empty, and then the data needs to go in from the first one from row 1, and we've got 18 pieces of data in ours. Once you've got the data finished, you're going to go to Document and Insert, and then Data and Statistics. And this will allow us to draw a graph of our data. We then need to click to add on what our variables will be, because at the moment everyone might have different and it looks quite random. At the moment it doesn't really show us anything. So we're going to add our years, so our timeline of when they happened should always be along the x-axis, and then our variable will be our world record, and that's the y-axis. So we've got the independent and then the dependent axis. And that now looks more like the graph we're expecting to see of the world record holders. Once you've done this, we're then going to need to draw our line of best fit, which is Menu, Analyze, and then Regression. So that one's Menu, Analyze, and then Regression. And you can pick which one you want to use, and it would be nice to try a few different ones. So we're going to do this example with the linear. So show linear mx plus b. We can pick up our label and move it if it's in the way, and that's the equation of this line. And it would be the same if we picked the cubic or the quadratic or the exponential or whatever else you wanted to do. So if you want to pick a different one, we go back through it. Regression just means line of best fit. We hide one and then we go and pick a different one instead. Once you've got your line of best fit, we want to find out when that will cross the answering question. So for example, the 9-second line for this one. And the only way to do that is to plot it into a new graph, because at the moment my graph doesn't go low enough to have 9 seconds. It stops with the last piece of data at 9.6. And there's no way for us to extend that. So we're going to go back to the home page and we're going to open a graph. And we can now plot in here the same function or the same graph name that we had for our line of best fit. So if you want to swap between the ones that you've had open so far, you just click along the top there. So the graph was minus 0.007953, and we're now going to type that in here. So minus 0.007953x plus 10.472, and we press enter. So this one here. And at the moment we can't see the graph. The reason for that is because it goes to 10 and then down to about 100. And at the moment we're looking from minus 10 to 10, and we're only going up to 6. So we're only looking at like this little tiny section here. We can't see the graph, it's outside of our window. So we can either double click on these and then we can change them to different numbers, or if it's easier, if you've got to change a lot of things, you can go to Menu and Window Settings, and we can change to whatever values we want. So for example, the x-axis, which is across here, maybe we want to go from -1. -1 is normally nicer than 0 because it lets you keep the axis on there. And then maybe we want to go up to about 100. That was what we had on our last one. And the y-axis, the one that goes up the top, the vertical one, we want to have a minimum value of, again, just about -1, and a maximum value going all the way up to maybe 12. And hopefully this time we can see our graph on there. It might be that you decide you don't really need this bottom part because we're only going up to 9, in which case we could go back into that and we could change the y-axis, the minimum, to be about 7. And then we're only looking at that top part, so you get to see a bit more detail. But because that graph then disappears, I think it's nicer to have it set on the first setting, which is the -1. Oops. There we go. Because now you can still see that axis, which is better for your labeling in your project. Now I'm going to move this out of the way, because later on I think that's going to get in the way to what I'm doing. And I'm going to want to extend this out. If I press tab, that will let me draw a second graph, so function 2. So it's a second line, and the world record was at 9. So the graph at that, the label for this one here is just y is equal to 9. So all I need to do is type in 9, and that draws on the line of 9. So that is always whatever it is that you want to check. It's the question that you're answering. And we want to find out when our world record, the blue line, crosses the 9, which is the red line. But it happens further along, so I need to double click this and just make it a little bit bigger. Maybe even a little bit bigger again. It's just guessing until you can find where that intersection happens. So it's about here that the lines cross. To find what that intersection is, I'm going to click on Menu, and then I'm going to go to Analyze Graph and Intersection. And that's telling me it's the point where two different lines or graphs meet each other. And this becomes like a little window that I'm going to open up. So it's asking at the moment for my lower bound. So I can click somewhere near the intersection. And I'm going to drag it until it goes over it, and then I'll click again. And it tells me there that my point of intersection is 185.9. So that tells me that the x-axis, the number of years, is 185, and it goes up to 9 on the y-axis, which is good because I want to know when will someone do it in under 9 seconds. Now my first bit of data was 0. That was the oldest bit of data I had because this was the years after the world record. So that record actually happened at 1912, and therefore I need to add on 185 to find out what the actual year will be at this point, which is then 2097. So we're estimating that the year 2097 is the first time that the world record for the 100 meters will drop below 9 seconds. But I need to have a think about whether that's really accurate. Maybe the line we picked wasn't the best line. We can see here it looks like a lot of them are under here, but then they're above it here. And then suddenly everything's got very quick here. So maybe that wasn't the best line. So I could go back to that and I could change it. So analyze regression, and I could hide the linear, and maybe instead I could choose something like a cubic. Maybe that follows it slightly better. And then I could do this part exactly the same again, but this time I would draw it with this graph, and we could see if that happened to be a different year. And we could talk about which one would be more likely. So that's a little bit of information on how we can use the GDC to do some modelling. And then you're going to be using this for your own project as well.